Not that thing now.
Okay, let me just record this. All right, I want you guys to understand the basis um of internet protocol. We have two models we use in networking. We have what we call the OSI model and the TCP/IP model. Now, the TCP/IP model, I said, is what we use professionally on the field, while we use the OSI model for explanatory sake and in the classroom. Now, but they all has, they all present the same thing to us. Okay. If you look at the OSI model here, I try to compare the two together, the OSI model and the TCP/IP model. The OSI model, we have 7 different layers. The OSI model, we have 7 different layers, while TCP/IP model, we have 4 layers. While some layers of OSI model have been have been moved together for easy collaboration. Okay. Now, but they mean the same thing. When you look at the physical layer on the OSI model and the data link layer, they are both merged together to form the network access layer that we have in TCP/IP model. Okay. You look at the network layer, is the same layer we have on TCP/IP model that is referred to as internet layer. The transport layer is the same layer we have on TCP/IP model as transport layer. The application presentation and session layer are merged together as application layer under TCP/IP model. There's no difference. They all mean the same thing and do the same work. But based on the interpretation and the inversion might be different. Okay. When you look at the physical layer, I told you earlier that your computer only understand only two things, is either on or off, which is 1 and 0, which give us binary transmission, that's binary digits. So that this is the point where we have our physical signals, our media signals. Is it working? Is it on? Is it connected? Is it green from amber to green and all that? Where you're trying to put put your put your physical gadgets together and devices and all of that. That is where you have the physical layer, and that is where the gadget, the devices accept your binary digits information and transmit into the system and move it to the data link layer, which is layer 2, for MAC addressing, which is your physical addressing. Remember, we have the private addressing and the public IP addressing. This is where your internet protocol addressing takes place. Now, 4 people can be in the same time. When message is sent to that time, it will be referred to just one person. The person which it is referred to, that is the person that is meant to respond. So you can have 4 different devices, 4 different hosts on one network. But if A is sending to B, C can receive the signal but cannot open it because it was not meant for that address, and it cannot respond, cannot reply because it wasn't meant for that address. That is where the physical addressing takes place. And this is where your Ethernet layer takes place. Like I said earlier, that you don't need the internet layer to communicate. In as much that as you are under local area networking. And this is the limitation we have in those days before the 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 internet invention comes in. Remember those days when we have Nitel, that cables will be connected from one house to another, and when one house is being disconnected, it's going to affect you. These are these are Ethernet kind of layers that affect us, that gave birth to internet, that we have to communicate um outside a geographical location. That our location should not limit us. You can be in this class but might not be in this country. But formally, we cannot do this. We have to come under the same geographical location. You must be in class before you can attempt this kind of learning. Okay, that's what gave birth to network layer, where we have the logical addressing system, and that is where the capsulation takes place, because it has to move from bit to frame, from frames to packet, from packet to segment, where it's going to be decapsulated and go on transport system. When it's going on transport system, this is where you have your intermediary devices. That is the transportation system. Okay. Now, on your transportation system, that is where you have end-to-end connections and reliability. This is where, as a cybersecurity professional, network security, where your major task is to make sure that your transport system is well secure, 100% secure, fully secured. And there's no way those things can be secure until you understand your physical layer, your data link layer, and your network layer very well. Whether you are the architecture of those layers or you are not, or you are or someone just set up the network system, the design, and just give you to run with it. It's been implemented before you take over the system. You have to see then understand which is which. What is my physical layer here? How many gadgets do I have? How many hosts do I have? Which host is bearing this address? Which host is bearing this address? Like I said, was it day yesterday or day before yesterday that we have three stages in communication system? We have number one, what? We have the sender, we have the receiver, and we have the medium. I am the sender, you are the receiver. The medium is our MTN or Airtel, whichever we are using. But technically, I am not the sender. My IP address is 192.168.20.11. That is the sender. It's not Joel, right? Then my default gateway happen to be my medium, while your own IP address happen to be the receiver. Okay, now that is what we are talking here, that moves through the transport system and now goes to the session layer. Remember I said at that at that packet level, decapsulation takes place. As I explained yesterday, difference between decapsulation and encapsulation, even though we are not there yet, but we'll soon get there in the next few chapters. You understand better what is encapsulation and decapsulation. Okay. Now, after your transportation system, it moves to session layer, where you have your inter-host communication. The hosts are communicating with each other, my end and your own end. Okay, am I the rightful owner of this message? Is this data meant for me? Can I decapsulate it? That is where we now have the presentation system. It's been presented to you in an encrypted format. If you look at WhatsApp, you're sending message, it will tell you end-to-end encryption. That's to tell you that if there's any rogue network in between, it cannot decrypt what I'm chatting with you, because my message, the message I'm sending from my end to your end is encrypted. Okay. Now, when we now have the application layer, that is where we have the hypertext languages that we use to communicate. Remember, we have the Ethernet, we have the IP, Internet Protocol, we have the TCP, and we have the HTTP. If you remember those four stages of communication. Okay, those are the four protocols we have. Then we now have the layers that is being explained over here. Okay, under the TCP/IP, the physical layer and data link layer is being merged together. Under the internet, under the TCP/IP, the network layer is referred to as internet layer. Under the TCP/IP, the transport layer of OSI model is also referred to as transport layer. While under the TCP/IP, the session layer, presentation, and application layer of OSI model is being referred to as application layer under the TCP/IP. But they all meant the same thing. But for the purpose of understanding, that is why the OSI model is being broken into 7 different layers. So we can understand how your message move from one end, from the sender to the receiver, and the medium in which you use to send the data, your packet, how it moves. Okay, so that is the OSI model and um the TCP IP model. Any question, please? Okay. Now we're talking about the rise of Ethernet. How the Ethernet migrate to internet. Okay, there have been various development in the internet system or in the networking system from one level to another. Somebody just sat down one day and say, "Oh, fine, I have my gadgets. I think my gadget should be able to work with your own gadget. I don't need to start looking for." I think the ISD, I mean, this guy then should be like 5 MB of or 10 MB. I remember when we used to have 50 MB megabyte as the highest, and anybody that has 50 MB then, man, you're a big boy. You store information worth 50 MB. That's quite large. But then it happened that we cannot start using diskette all the time. We have to look for a way to communicate between one computer to another. There comes Ethernet. As we have Ethernet, that is in the early days of networking, a challenge came up with Ethernet. That is, a host can only communicate with a similar host. That means IBM can only communicate with IBM. Hewlett Packard can only communicate with Hewlett Packard. Those were the two major technology we have those days in computer. It's either it's IBM or it's HP. It was not even formerly HP. It was amalgamation that brought them to be HP. Before we now have Compaq, we have Compaq HP and all that. Before Compaq is being fade away, before we now have Lenovo, Sony, and the rest of them. But those days, these gadgets cannot communicate with each other. It's just like how we have Android and iPhone today, that they cannot communicate. Okay, so these are the stages in which Ethernet have gone through. So they now come to what is referred to as standard. We have what is called IEEE 802.3 Ethernet. We have 8024 ARCnet. We have 802.5. But at the end of the day, after um, considering one thing or the other, we'll be able to agree on what is 802.3. Now, as the as the Ethernet protocol, which we use to communicate within one gadget to another, in which IBM will be able to communicate with Xerox. Xerox will communicate with HP. HP communicate with DEC and the rest of it. So now we have the evolution then that I'll just explain. We have 802.3, then okay, will watch this video later on me. On the portal. Then we have the Ethernet MAC address that I explained earlier, where we have the physical addressing, that is addressing your network interface card. All communication refers a way to identify the source and destination. That is you and myself must be identified. Okay. Sorry, please. Now, you and I must be identified. And that is what we refer to as media access control address. That is MAC address. Every Ethernet network interface has a physical address assigned to it when it is manufactured. This address is known as media access control address. That is MAC. This MAC is unique to gadgets. My MAC address is different to your own MAC address. This is one of the ways in which we track stolen devices. Okay, but we are not going there. Going that route today. In this lab, you will complete the following objectives. Determine the MAC address of a Windows computer on an Ethernet network using ipconfig/all command. We have done something similar to this before, but you're going to try it on your own before tomorrow. So making this the second this thing now. Assignment I'm giving you. If you don't submit any one of it tomorrow, I'm not going to allow you into the class. Now, this is the end of Ethernet that we need to understand. That is completing the communication principle that we started in chapter 5. So by tomorrow, we'll be moving to chapter 6. And if there's any
Okay. That's the only way. No other means.
H1 has the source MAC address. MAC stands for Media Access Control.
All right, sir.
Source
Thank you.
MAC address of all A's. So let's go ahead and start the animation. And we can see that host H1 has a Ethernet frame to send to host H3. So in the Ethernet frame, there is a destination MAC address. This is the destination MAC address of host H3. As you can see, it's all C's. The source MAC address is that of host A, all A's. So H1 sends that Ethernet frame to the switch. When the switch receives this Ethernet frame, in this case, it's going to forward the Ethernet frame out all ports except the incoming port. Later, we'll learn more about how Ethernet switches can actually filter the frames so that they only send the frame to the destination itself. We'll learn about that a little later. But as you can see, that all the devices on the network receive the Ethernet frame. H2 and H4, these two hosts, ignore the Ethernet frame. Why do they do that? They examine the destination MAC address, all C's, with their own MAC address. Actually, the Ethernet NIC card does this. Because it is not a match, the Ethernet NIC card will ignore the rest of the frame, ultimately just not receiving this message. H3, its Ethernet NIC card, when it receives this Ethernet frame, it compares the destination MAC address in the Ethernet frame to its own MAC address on its NIC card. Because it is a match, it goes ahead and receives the rest of the frame and the message gets processed.
Okay, that better explain what I've been explaining to you about Ethernet MAC address, about Ethernet, about MAC addressing, the media access control, and all that.